Let me start the recording. Okay, so uh, let us begin now. Okay, so till now we have seen the three different methods to find out the root of a given equation. That is the bisection method, regular falsi method, and the Newton-Raphson method. And with that, we have completed one unit. It's a very small unit, and I have already given you the assignment, so it is expected that all students will submit the assignment within the due date. Okay, I am going to give you 6 assignments, each assignment carrying 5 marks, so total 30 marks will be there. So one assignment for one student. Okay, sorry, one assignment for one unit. So accordingly we have 6 units, so total you have to submit 6 assignment, every assignment carrying 5 marks. Okay, so please submit the assignment, and let us start with the today's topic, that is the Newton's forward difference method. So here, this Newton's forward difference method is a part of your interpolation and extrapolation. Okay, so first of all we need to understand what do we mean by interpolation and extrapolation. So let us say you are doing some experiment. Okay, and in that experiment, for example, you have collected some data, and that data is represented in terms of x and y coordinates. So for example, we have data which is something like this. Okay, and we have one point over here. Let us say this is x, this is another x, this is another x, and this is also another x. Okay, so for example, if you plot a straight line which is probably like this. Let us say this is a straight line, this is a value of y, again this is the value of y, again this is the value of y, and again this is a value of y. Okay, so we have, let us say here, this is your x1. Okay, x2, x3, x4, corresponding this is your y1. Okay, y2, y3, and y4. Okay, so this side we have x, and this side we have y. So if you join these points, so you are going to get a curve which is something like this. Okay, so if this is the case, then we have already these 4 points: p1, this is p2, this is p3, and this is p4. So say p1 here, p2 here, p2 p p over here, and this is p4 over here. Okay, so now what do we mean by interpolation? So for example, if we want to calculate what is the value of, let us say, y at this point. Okay, because sometimes we need to find out the intermediate values. So here if you draw a straight line, it will be something like this. Okay, so I need to find out what is this y value. So basically, when your x, okay, so x is lying between x1 to x4, that means the points which are available with us, and we want to find out the y value of x which is lying between the given data set. In that particular case, this is called as interpolation. Okay, and if it is lying beyond the data set, let us say you want to predict what is going to happen when your x is over here, something like this. So right now you can see your x. Okay, x is not there in between x1 to x4. Okay, so it can be beyond x1, or it can be even before the x1. In that particular case, it is called as extrapolation. Okay, I hope this is clear to everyone what is interpolation and extrapolation. Okay, so for this purpose, for interpolation and extrapolation, we have different methods. The first method which we are going to study today is the Newton's forward difference method. Okay, so this Newton's forward difference method, I am just writing down the equation for you. So here the predicted value of y can be calculated in this particular fashion. So I want to calculate this y. Let us say this dotted line, or maybe this dotted line, this can be y. So whether it is interpolation or extrapolation, the formula remains same. Okay, formula remains same. Only thing is the interpretation is different. So if the point is lying between the data set, it is called as interpolation, and if the point is lying beyond the data set, it is called as extrapolation. But the equation remains same. So let me just quickly write down. So y can be calculated by a simple expression y0 plus we have p times delta y0. Okay, plus this is p into p minus 1 divided by 2 factorial times delta square y0. Okay, then this will be p into p minus 1 into p minus 2 divided by, now this will be 3 factorial into delta cube y0 and so on. Okay, so in short, the equation is something like this. This is p into p minus 1 into p minus 2 and so on, let us say up to p minus n. So if it is p minus n, then in that particular case, okay, this will be n minus 1 factorial. Okay, into this will be something like delta to the power n times y0. Okay, now you need to understand this, what is p and what is delta. Okay, so this p is calculated by a simple expression, that is x minus x0 divided by h. Now this x is nothing but this x. Okay, either this x or this x जिसका हमको y निकालना है. So this is nothing but this x. X0 is nothing but the first value. Okay, so in here I have written x1, but this is the first value of the given data set, and h is the interval. So here you see we have x1, x2, x3 and x4. So the interval between x1 and x2, or the interval between x2 and x3, or the interval between x3 and x4, it is constant. Okay, so this constant is nothing but your h. So this is the difference or the interval between the two consecutive values of x, which will be always constant. Now as far as this delta terms are concerned, okay, so this delta terms will be calculated from a simple table. Okay, just to understand this, let us quickly take a simple example. Okay, so let me take an example over here. Example 1. Okay, now in this example, let us say I have a table. uh, Let me insert a table. Okay, so here we have year and here we have population. Okay, so in the year 1891, the population of any city is 46. Okay, then in year 1901, the population of that city is 66. Then in year 1911, the population has become 81, and in year 1921, sorry, this will be 1921, the population is increased to 93, and in year 1931, the population is now 101. Okay, so this is the data which is available with us. So here basically we are predicting the population, and it can be your experimental data also. You can perform some experiment. Let us say you are increasing the load and you are getting a deflection value. Okay, so you can have the incremental load and you can have the deflection in the y-axis, and then we can predict what will be the deflection at certain amount of load. So this can be simply used over here. Now coming back to the this particular data set. So now here you can see this particular year can be taken as x and this can be taken as y. Okay, so if you draw a curve, it will look like this one. Okay, so here we have one column. So here this will be 46, this will be 1891, this will be 1901. So this will be again, this is 46, then this will be 1911, this is 81. Okay, then we have 1921 and we also have 1931, and you can see this graph is continuously increasing. So if you draw a curve, it may look something like this. Okay, so now for this particular purpose, now we need to find out in the in the numerical it is given that what will be the population. Okay, what will be the population in year, let us say, okay, in year 1895. Okay, so our object is to find out what will be the value in 1895, because we have the data of 1891 and 1901, we don't have the data of 1895. So with the help of this integrate this interpolation technique, now we can find out what will be the population in that particular year. So now you see the data of 1895 lies between the data set. We have a data set from 1891 to 1931. Okay, so this value lies between the given data set. So that's why we will call this as interpolation. Okay, okay, so that's why this will be called as interpolation. So now let us quickly see. The first thing is we need to find out what is the value of p. So if you remember, p is nothing but x minus x0 divided by h. So now this x is nothing but this value, that is 1895, for which we need to find out the value of y. Okay, your x0 is the initial value or the first value of x. So if you refer this table, this is this value, that is 1891. Okay, and as far as h is concerned, h is nothing but the interval or the distance between or the difference between the two consecutive values of x. So if you take any two consecutive values of x, you will find the difference is 10. So we have a data of population after every 10 years, isn't it? So this is nothing but your 10. So the value of p now will be simply 1895 minus 1891 divided by 10. So can anybody tell me what will be the value of p? 0.4. Okay, so this is the value of p. Okay, so now if you refer this particular table or this particular equation, you have y is equal to y0 plus p. So p is calculated. Now we have to calculate what is the delta y0, delta square y0, delta cube y0, and so on. Okay, so for this purpose, what you have to do is you have to draw a simple table. Okay, so let me draw a table for you. Um, for this purpose, I need to slightly go down and uh, let me. Okay, so I have some this table like this. Okay, so what I'm going to do is, first of all, I'm going to substitute the value of x and y. Okay, so if you refer these values, the x values available with us is 1891, then this is 1901, then we have 1911, then 1921, and then 1931, right? Now about y values, so y values, they are nothing but your population. So in year 1891, the y value is 46, then we have 66, then we have 81, then we have 93, and then we have 101. So I have just written a simple table. Now in here I have to find out these delta coefficient, that is delta y0, delta square y0, and delta cube y0, and so on. Okay, so here I am going to write down this value is nothing but your delta y0. Okay, so in the Newton forward forward difference method, this delta y0 is nothing but the difference of two consecutive values of y. Okay, so here basically this will be something like 66 minus 46. Okay, so 66 is what? 66 is this value. Okay, the value of y in the next year, and this is the value of y in the current year. So this is 66 minus 46. How much is this? I think 20. Okay, so this is nothing but a 20 value. If you refer the next value, so this will be something like 81 minus 66. So 81 is over here, so this is the next year's value, and this is the current year value. Okay, so how much is 81 minus 66? Somebody please calculate. 50. Okay, similarly over here this will be 93 minus 81. What will be the value? 12. And what will be the last value over here? 101 minus 93. So its value will be 8. Okay. So this is nothing but your delta y0 value. Okay. I'm selecting this and I'm just keeping the first value. I'm just changing the first value to bold value. Okay. Then in the second column, I'm going to calculate, this is nothing but delta square y0. So this delta square y0 can be calculated in the similar fashion. Now in this case, this will be 15 minus 20. Okay, so 15 is nothing but this value. Okay, which you have calculated in the next year, and this is the current year. So this will be 15 minus 20. So if you calculate this, so this is becoming minus 5. Okay, what should I write over here? Yes, anybody? Sorry? 12 minus 15. Okay, so that is coming out to be minus 3. And what should I write over here? 8 minus 12. So it is coming out to be minus 4. Okay, so this is delta square y0. I am just making this value as bold. That is the first value as bold. Okay, then here this is delta to the power 3 times y0, delta cube y0. So here again we are using the similar technique. So this will be minus 3, okay, minus of minus 5. Barabar hai? Okay, minus 3 minus of minus 5. So this comes out to be 2. And lastly, this will be minus 4 minus of minus 3. Okay, and if you calculate this, this is coming out to be minus 1. Okay, so here I am just making the first value as bold one, and lastly this will be something like delta to the power 4 times y0, and of course यहाँ पर क्या आएगा अभी? minus 1 minus 2, so this comes out to be minus 3. Okay, so I am just making this value as bold. So remember what I have done. I have done some calculations, and the first value which I am getting, that is in the first column of delta y0, I am getting 20. So I am making this as bold because I am going to use this value. So this table indicates the value of delta y0, delta square y0, delta cube y0, and delta to the power 4 y0. All we have to do is you have to choose the only first value. Okay, now coming back to the equation. So this is our equation. Now we know the value of delta y0. We know the value of delta square y0. We also know the value of delta cube y0, and so on. So right now, if you see, we have a values of delta y0 up to delta to the power 4 y0. Okay. So our final equation, because if you see, this is a unending equation, right? So our final equation will be something like this, because it must have a value which is up to delta to the power 4 y0. Okay, so your capital Y now will be something like y0 plus p times delta y0. Okay, plus we have p into p minus 1 divided by 2 factorial, okay, into delta square y0. Okay, then we have one more term, p into p minus 1 into p minus 2 divided by 3 factorial into delta cube y0, plus we have p into p minus 1 into p minus 2. Now this will be p minus 3 will also come into picture. Okay, and this will be 4 factorial, and this will be delta to the power 4 y0. Okay, that's it. No more further, because we don't have delta to the power 5 y0 term. Okay, So now all we have to do is just substitute the values correctly. So y0 is nothing but the first value of the data set. So this is nothing but your y0, the first value of y. So this is nothing but your 46 plus p value you have already calculated as 0 0.4. Okay, so this will be 0 0.4 into delta y0 is nothing but this value, that is 20. Okay, the first value, so this is nothing but 20 plus p value. P value is zero point 0.4. This will be zero point 0.4 minus 1 divided by 2 factorial is 2 into 1. Okay, now delta square y0 is nothing but this term, that is minus 5, the first term. So this will be minus 5. Okay, then the third one, that is p, that is 0 0.4 into 0 0.4 minus 1 into 0 0.4 minus 2 divided by, now we have 3 factorial, so this is 3 into 2 into 1 into delta to the power 3 y0. So delta to the power 3 y0 is nothing but this value, that is 2. Okay, plus now we have, this is zero point 0.4 into zero point 0.4 minus 1 into zero point 0.4 minus 2, sorry, zero point 0.4 minus 2, then 0 0.4 minus 3 will also come into picture, isn't it? Divided by 4 factorial is 4 into 3 into 2 into 1 multiplied by delta to the power 4 y0 is nothing but minus 3. This is coming from here. Okay, so now you just do the calculations and give me the value of this. Sorry,
54.5419.
someone please cross check this whether it is correct or not.
54.8528.
Yes, that is the correct one. 54 point.
8528.
Okay, please check your calculations, everybody should get this value.
54.8528.
कोई है ऐसा जिसको ये वैल्यू नहीं आ रहा है? ठीक है, so if you go back to the graph, so what we are getting over here is this column. Okay, this column. Okay, so this column is the value of y and we are getting something like 54.85. Okay, so this will be the population of a certain city in 1895. Okay, so you can see it is lying exactly somewhere in between 46 and here this the value was 66 over here. Okay, so this is called as an interpolation because the year 1895 is lying within the data set which was given to us. Okay, so this is how what is called as interpolation. Okay, I hope everybody has understood this. Yes.
Yes.
Okay, so we will take one more example and this time we will go for extrapolation. Okay, so let us say this is example 2. Okay, so in this what we are going to do is we'll take simple values. Okay, so some values are given to us, so the values are like this. So directly I'm writing down the x and y values. Okay, so this is x and this is say y. So the value of x is something like 0, 1, 2 and 3, and the value of y we have like 1, then we have 0, then we have 1 and then we have 10. Okay, so if you plot a curve of this particular expression, it may look something like this. Okay, uh, okay, so here we have the value of y as 1 over here. Okay, then the value is coming 0 over here, then the value is 1 over here, and for 3, so this will be 3, the value will be very high, that is 10. So the graph is looking like this. Okay, so this is, so here this will be, say, 0 0, this is 1, this is 2, and this is 3. Okay, so now this is how your graph looks like, and what is asked over here, what will be the value of y when x value is, let us say, 4. Okay, so here we have x equals to 4. Okay, so what will be the value over here? So now in this case, if you see the value of x, ये वाला जो value है, this value is lying beyond the data set. Okay, so we need to find out what is the value of y over here. So it is beyond the data set, so that's why this particular method will be now called as extrapolation. Okay, so this is called as extrapolation. Okay, since it is not lying within the data set, so it will be called as extrapolation, right? So for extrapolation, the same equation is applicable. Okay, so first of all, we need to calculate the value of, let us say, p. Okay, and if you refer this p value, so p value is what? P value is nothing but x minus x0 divided by h. Okay, so here this is nothing but x minus x0 divided by h. So this x is nothing but this value जिसका y निकालना है. x0 will be 0 because this is the first value. Okay, and h is nothing but the interval. So you can see the interval between the two consecutive values of x is nothing but 1. So this will be 1. So your p value is nothing but 4 minus 0 divided by 1. So your p value will be nothing but your 4 value. Okay, now since p value is calculated, all now we have to do is generate this particular table. Okay, so let me generate a table for you. I'll be creating a table over here. So let us say insert, and we have some table over here. So I'm going to write down over here, this is x value and this is y value. Okay, so your x values are starting from, say, 0 1 2 and 3. Okay, the corresponding y values are 1, then we have 0, then we have 1, and then we have 10. Okay, so now I'll be working on the delta y0. Okay, so delta y0, what should I write down over here? Anybody?
1 minus 0.
No,
0 minus 1.
0 minus 1, because it is next value minus the current value. So this will be 0 minus 1. So this is going to become minus 1. Okay, how about this one? इसके नीचे क्या आएगा? 1 minus 0. So this will be plus 1. Okay, and how about this one? Yes, 10 minus 1. So this is going to become 9. Okay, so out of these three values, we are going to use this value, that is the first value. Okay, now in the second column, I'll be using delta square y0. Okay, so now can anybody tell me what should I write down over here? 1 minus of minus 1, correct? So this is going to become 2. Okay, and here what should I write? 9 minus 1. So this is going to become 8, out of which I am going to make the first value which will be used. Okay, then here I'll be having delta to the power 3 times y0. So what should I write down over here? 8 minus 2, that will be nothing but the 6. Okay, so I'm making this as a bold. Okay, I don't need to go for delta to the power 4 y0 because our data set is limited. We have only 4 values, so we'll be getting only 3 deltas. Okay, so your final equation of y will look something like this. Okay, so your capital Y will be now y0 plus p into delta y0 plus this will be p into p minus 1 divided by 2 factorial into delta square y0. Okay, plus one more term will come because we do have a value of delta to the power 3, so this will be p into p minus 1 into p minus 2 divided by 3 factorial into delta to the power 3 y0. Okay, so let us quickly substitute the values. Y0 is nothing but the first value of y, so first value of y is this one, that is 1. So I'm going to write down 1 over here plus p value is nothing but 4 and delta y0, so here this delta y0 is minus 1. Okay, plus p value is 4, this is 4 minus 1 divided by 2 factorial is 2 into 1. Now into delta square y0 is nothing but your 2. Okay, plus this p is 4, this is 4 minus 1 into 4 minus 2 divided by 3 factorial is nothing but 3 into 2 into 1 into delta cube y0 is nothing but your 6. So this 6 is coming from here. Okay, so now can anybody tell me what will be the value of y?
Sir, sir, 33.
Sorry,
33.
exact 33,
Yes, sir.
no digits.
No, sir.
Okay, everyone is getting this 33 answer.
Yes, sir.
Okay, so basically when the value of x is uh, 4, the value of y will be now 33. Okay, so here we will be getting this value as 33. Okay, so this is what we call it as a extrapolation. Okay, so now I want all of you to find out what will be the value of y when your x value is somewhere over here, that is minus 1. So this time I'll be using the value which is earlier to the database. Okay, so can you do this? Because see,
Yes,
this table is going to remain same, this table is going to remain same, all we have to do is just change the value of p. So here in p value, the x value earlier it was 4, now it will be क्या रहेगा अभी?
minus
Minus 1, isn't it? So in this particular case, your p value is x minus x0 divided by h. So x value will be now minus 1, x0 will be 0 divided by 1. So this is going to become minus 1. So this entire thing will remain same. Only thing is the value of p is now changed. Give me the value of y then.
minus 4.
Sorry.
Minus 4.
Someone please cross check this.
Sir, minus 4.
Sir क्लासमध्ये आहे. हां ठीक आहे, नंतर बोलतो सर मी, अर्धा तास आहे अजून. ठीक आहे. हाँ, yes, students tell me what will be the value of y.
Minus 4. Minus 2.
कोई -4 बोल रहा है, कोई -2 बोल रहा है. करें? ठीक है, चलो करते हैं. ठीक है. So the y value, so here y0 will remain same, so y0 is 1. Okay, plus p is going to become -1. Okay, and this delta y0 will remain same, ये तो चेंज होना नहीं है. ठीक है. Then we have p value is -1 into -1 minus 1 divided by 2 factorial is 2 into 1, and this value is nothing but your 2. Okay, plus p value is -1, so this will be -1 minus 1, then we have -1 minus 2 divided by 3 factorial is 3 into 2 into 1 into this will be nothing but 6. अब बताओ.
Minus 2, sir.
माइनस
2. 2. Yes, sir.
पक्का?
Sir.
minus 2. Okay, so here this value, okay, so if you plot a curve, so this will be nothing but minus 2. Okay, this will be also called as extrapolation because the value of x is not lying within the data set, it is lying beyond the data set. Okay, so this is on the earlier side, the other value was there in the higher side. Okay, lower side, higher side, irrespective of whether it is interpolation or extrapolation, this equation is used. Okay, only thing is it's just a matter of interpretation. If the value is lying between the data set, it is called as interpolation, otherwise it will be called as extrapolation. Okay, I hope this method is clear to everybody. कोई क्वेश्चन,
Yes.
कोई सवाल है?
No, sir. Clear.
ठीक है, ठीक है. Okay, so we will stop over here, we will continue tomorrow with the Newton's backward difference method now. Okay, so everybody, you can leave the meet now. If you have any queries, we can discuss, otherwise you can leave the meet.